this video, we are going to discuss about the working principle of the chiller. We can see chillers in the large buildings. And there are many types of chillers. But there are commonly two types of chillers. One is air-cooled chiller, and another one is water-cooled chiller. Although there are many types of chillers, they all have the same components and same working principle. Now, let's see the main components of the chiller. Compressor, condenser, evaporator, and expansion valve. Compressor is an important component in chiller. This is used to make the refrigerant flow throughout the chiller. Commonly, there are four types of compressors. They are centrifugal compressor, screw compressor, scroll compressor, and reciprocating compressor. Next, condenser. The important job of the condenser is to reduce the temperature of the refrigerant entering it. In water-cooled chiller, we use water to reduce the temperature of the refrigerant. In air-cooled chiller, we use air to reduce the temperature of the refrigerant. Next, expansion valve. Its function is simple one. It reduces the pressure and temperature of the refrigerant by expanding the refrigerant coming from the condenser at high pressure. There are four types of expansion valve. Thermal expansion valve, pilot-operated thermal expansion valve, the electronic expansion valve, and fixed orifice expansion valve. Last, evaporator. The evaporator reduces the temperature of the water coming from the AHU with the help of refrigerant and sent back to the AHU. Now, let's see its working principle. The compressor sends the refrigerant to the condenser from evaporator, which is in the vapor phase. The water coming from cooling tower enters the condenser at 32 degrees Celsius through the copper tubes. This water travels throughout the tube. In the condenser, refrigerant travels around the copper coils. As per the thermodynamics law, the high temperature travels towards the low temperature. So, as per the law, the heat of the refrigerant, which flows around the copper coil, will transfer to the water, which flows inside the copper coils. Because the refrigerant temperature is higher than the water temperature. So, the water temperature will increase. The water comes out from the condenser at 40 degrees Celsius. As the temperature of refrigerant decreases, it changes from vapor phase to liquid phase. Next, the refrigerant travels to the expansion valve. The expansion valve reduces the pressure and temperature of the refrigerant, which comes at high pressure and high temperature. The second role of the expansion valve is to send the required amount of the refrigerant to the evaporator. A thermal bulb from the expansion valve is connected to the outlet of the evaporator. With the help of this thermal bulb, the expansion valve sends the required amount of refrigerant to the evaporator depending on the temperature of the evaporator outlet. Next, the refrigerant will enter into the evaporator. The evaporator is also similar to the condenser. In the condenser, the water from the cooling tower enters through the coil. But, in the evaporator, the water from the AHU enters through the coil. The water from the AHU will enter into the evaporator at 12 degrees Celsius and it will travel throughout the coil. The refrigerant that comes in cold from the expansion valve surrounds the coil inside the evaporator. According to the law of thermodynamics, the heat of the water will transfer to the refrigerant. Because the water temperature is higher than the refrigerant. As the heat of the water goes to the refrigerant, the water cools down and comes out of the evaporator at 6 degrees Celsius and goes to the AHU. As the temperature of the refrigerant increases, the refrigerant evaporates and goes to the condenser through the compressor. This process is continuous.